In this video, we'll talk about countdown latch. Countdown latch is a synchronization aid which allows one thread to wait for one or more threads before it starts processing. Simply put, a countdown latch has a counter field which you decrement as required and use it to block a calling thread until it's count down to 0. So, an example of countdown latch is you can use it as a join. So instead of joining the threads, you can use the countdown latch. And how you will use it? Inside the threads, you increase the counter, and once the thread finishes processing, you decrease the counter, and then the main thread is basically waiting for countdown to reach to 0. And when the other two threads, other two threads where the countdown is waiting for dies, then the countdown will decrease to 0 and the main thread will resume. So it's one of the functionality which you can implement with countdown latch is the join functionality. While doing parallel processing, we will initiate the countdown latch with the same value of the counter as the number of threads we want it to wait for. Then we will call await method in the main thread and call the countdown to decrease the counter inside each thread, the main thread waiting for to complete. Methods of countdown: await method, wait until the latch has counted down to 0. Boolean await with timeout, and countdown decrements the number in the latch. And get count, it returns the current value of latch. So now we'll be implementing an example of countdown. So what we'll be doing is that we'll be implementing the sum of 5000 number with countdown latch. To accomplish the sum in parallel, we'll be creating a new class sum of numbers using latch. Inside the class, we'll be creating two callable threads. First one will sum the number from 0 to 2500 and other will sum from 2501 to 5000. We will create a countdown latch instance with counter of 2. We'll call the countdown at the end of the callable threads to decrease the counter. We will use int stream to create a list of 5000 numbers. We will use executor service and will call the callable using submit to get the results in future object and sum the future objects once the await returns. Now let's implement this example in IntelliJ. So now let's implement the example. So click right and create a new class. The name of the class is sum of numbers using latch. Sum of numbers using latch. So first what we'll be doing is creating the public static int array from int stream. So we got number 0 to 5000 in the int array. Now let's, for verification purpose, we'll create sum using int array dot sum method. Static and total is equal to int stream dot range close 0 to 5000 dot sum. And we'll be creating an instance of countdown latch. So final static count down latch is equal to count. So we created an instance of countdown latch. Now let's create our public static void main. And inside public static void main, we'll be creating two callable instances. One will be summing the number from 0 to 2500 and other will be doing it from 2501 to 5000. So callable callable 1, and here integer sum is equal to 0, and for integer I is equal to 0, I is less than array dot length divided by 2 I plus plus. So here we are summing the number from 0 to 2500, and here we'll be adding the sum to the sum variable is equal to sum plus array of I. So here we need to initiate the countdown latch because we are running 2 threads, so we'll initiate with 2. Now we'll be doing the countdown on the countdown latch dot countdown. So once this thread finish processing, then it will count it down from 2 to 1. And callable thread requires return, so we'll be returning sum. Now let's create a second callable 2 is equal to and here int sum is equal to 0, and for integer I is equal to array dot length divided by 2 I is equal to array dot length and I plus plus. I is less than array dot length and I plus plus. Now we'll be adding to the sum variable. Sum is equal to sum plus array of I, and here also we'll be counting down the latch and return sum. Now let's create an executor service. So executor service is equal to executor dot new fixed thread pool of 2, and future, because we'll be getting the return object in the future of integer sum 1 is equal to executor service dot submit and callable 1. So we are just using the submit method instead of using the no call. So future and integer and sum of 2 is equal to executor service dot submit and callable 2. Now let's print out some individual sum. So here countdown. First let's print out the countdown latch count. Countdown latch count for calling the wait plus countdown latch dot count get count. So we are printing out the number of latches it has at this point, and we'll call the countdown dot latch, countdown dot await. So now we are waiting for those 2 threads to execute. and afterwards, once the countdown latch is finished awaiting, then let's print out the number of countdown latch count after await, and plus countdown latch count dot get count. Now we have sum in the, so let's create another variable. Sum is equal to sum of 1 dot get plus sum of 2 dot get. Now let's print out the sum. Sum from the thread is plus sum, and correct sum is plus total. This is the sum which we got from the int_array.sum directly, and at the end we will shut down the executor service. So let's look at the code again. So first of all, what we are doing is that we are creating two callables, and inside the callable we are decreasing the counter. Here we start the countdown latch with counter of 2, and within each callable we are decreasing the counter after calculating the sum, and then we are submitting those two threads or callable using executor service.submit, and submit will return us the result, where the result is, which is returning back, and this sum. So this sum will be will come back over here at some point in this future object, but it is not at this point available in the future object, so we'll have to wait until the threads finish processing, and that's what this is for. Countdown latch.await. This will get out once the countdown will reach to 0, in this case when both the threads will finish calculating the sum, and then afterwards we are adding the sum of the individual callable and printing it out. So you can see that countdown latch count before calling the await is 2, and after the await the countdown is 0, and sum for the thread is 1250250. So correct sum is 1250250. So this is an example of calculating sum of 5000 number using countdown latches, and here it works similarly as we have done with the join, where we waited for those two threads to complete the work. So countdown latch functionality is similar to the functionality which we can implement using joins in this example.